Hello everyone, today is September 11th, 2013. I'm working some problems that have come up on the discussion boards. I tried to answer this one. I remember typing out both of these, had nice long answers, and then something happened. Maybe I didn't hit post or something, and they all disappeared. So I'll work them out here. Okay, so it was negative 9 to the 0 times the quantity x squared y to the negative 2, that amount to the negative 3, over 3x to the negative 4y. Now, 9 to the 0 is just 1, so this is negative 1 times, and I don't need parentheses here. If I bring in that negative 3, x to the negative 2 to the negative 3, we multiply 2 times negative 3 is negative 6. Y to the negative 2 to the negative 3, negative 2 times negative 3 is positive 6 over 3x to the negative 4, y to the 1. There's no power showing, but it's just going to be a 1. So it's going to be negative 1 times, I have x to the negative 6 minus the power down below, negative 4, y to the 6 minus 1, 1's the power down below, divided by 3. So it's negative 1 times x to the negative 2, y to the 5, all over 3. So it's just going to be negative y to the 5th over 3x squared. Or you can write that as negative of y to the 5th over 3x squared. Either one of these are essentially the same. Now the next one, we have 3 to the negative 1 over 3 squared, x, y squared, all that to the negative 2. So it'll be 3 to the negative 1, not negative 3, Jeff. 3 to the negative 1 over, this is 3 squared to the negative 2, so that becomes, you multiply those powers, 3 squared to the negative 2 is 3 to the 2 times negative 2 is negative 4. X to the negative 2, y to the 2 times negative 2 is negative 4. All these being negative powers, we can of course bring them up. We end up with 3 to the negative 1 minus that negative 4, that power minus that 1, x to the positive 2. It's a negative power down below, goes up, becomes positive, and y to the negative 4. It's a negative power down below, comes up, and becomes positive. So we have 3 to the, that's negative 1 plus 4, so 3 to the 3, x squared, y to the 4th, which is 27, x squared, y to the 4th. Okay, hope that helps there. Then I have some questions from 1.7b. Let me find my notes. I had to rewrite these. It was emailed to me, and I wasn't quite sure what it was asking, but I figured it out. 5z to the 11/5 minus 26z to the 6/5 plus 24z to the, I believe it's 1/5 equals 0. So we want to solve this, and I would say first factor out your lowest power, z to the lowest power, and that's z to the 1/5. So that becomes z to the 1/5 times, we'd have 5z to the 11/5 minus 1/5 minus 26z to the 6/5 minus 1/5 plus 24z to the 1/5 minus 1/5. So I'm dividing it out, so I subtract those powers. So it's z to the 1/5 times 5z to the 11/5 minus 1/5 is 10/5, which is 2, 10/5, minus 26z to the 6/5 minus 1/5 is 5/5, plus 24z to the 0 power equals 0. So z to the 1/5 times 5z squared minus 26z plus 24. Now it's a matter of trying to factor this 5z squared minus 26z plus 24. So we can do 5 times 24 is 120. We'll look for factors of 120 that add to be negative 26. Now, given the fact that it's a positive 120 and they add to be something negative, both factors must be negative. This could be a long list. 120 has a lot of factors. I'm trying to think if there's a short, not really a shortcut here, but what is a shorter way to get there? Let me see here. Like negative, go negative 6 and, oh, look at that, negative 20. I guessed it, I wasn't even trying. I was going to start there and work my way up, but negative 6 times negative 20 is positive 120. Negative 6 plus negative 20 is negative 26. So this would be z to the 1/5 times 5z squared minus 6z minus 20z plus 24 equals 0. So that'd be z to the 1/5 times 5z squared minus 6z. Those are going to be grouped together. Minus now, by grouping these, I have 20z. This becomes a minus 24 because negative of 20z is negative 20z. Negative of negative 24 is positive 24. So it's z to the 1/5 times, from this first pair you can factor on a z. I'll leave this z, and we have parentheses. And that would be 5z minus 6 minus, from the second pair we could factor on a 4. Then we would have 5z minus 6. So we have this repeated factor. So it's z to the 1/5 times 5z minus 6 times z minus 4 equals 0. So z to the 1/5 is 0. That means z equals 0. Okay, need some more room here. 5z minus 6 is 0. Means 5z equals 6. Means z equals 6/5. And z minus 4 equals 0. Means z equals 4. So our zeros are z equals 0, z equals 4, and z equals 6/5. I believe this came from 1.7b. Okay. I don't know if it's number 1 or not. It's not. I should say it's not number 1 because I just went in there and checked and it wasn't number 1, but it was listed as the first one. The person wanted me to try. Number 2. That this person asked me to do. 3z to the 14/5 minus 15z to the 9/5 plus 18z to the 4/5. Now, the nice thing about this one is I can factor out not only a z, but this is a 3, that's a 15, that's an 18. I can factor on a 3 times z to the 4/5. So 3z to the 4/5 times, and dividing that 3 out, so that's gone here, and then I have z to the 14/5 minus 4/5. (15) divided by 3 is 5. Z to the 9/5 minus 4/5. then you could factor out from the 18, dividing 3 out, you get a 6 z to the 4/5 minus 4/5. When you do this a little more often, you could skip a few steps here. This is z to the 10/5 minus 5z to the 5/5 plus 6z to the 0. So it's 3z to the 4/5 times z squared minus 5z plus 6. So it's 3z to the 4/5 times z minus 3 times z minus 2. So we can set 3z to the 4/5 equal to 0. We get z to the 4/5 is 0, dividing both sides by 3, so z must be 0. Z minus 3 is 0, so z equals 3. Z minus 2 is 0, so z equals 2. So our solutions are z equals 0, 3, and 2, or 0, 2, and 3 if you like to do it in numerical order. Now I had some other questions. Questions came up about radicals, specifically cube roots, and I was not able to get any specifics from anyone what they wanted, so I'm going to just have to pick and choose and hope I find something that the person really meant to see. So I'm looking in the book right now, 1.2, number 66. We have the cube root of negative 27. So with this, we're trying to think of a number times itself. That's going to be negative 27. And that's just going to be negative 3. Negative 3 times negative 3 is positive 9, times negative 3 is negative 27. Here's 72. I realize these aren't ones I assigned for the homework, but this person was asking for something, I think, out of the online homework. And that doesn't always distinguish between evens and odds. Okay. The negative of the cube root of negative 8, so it's a negative of, well, the cube root of negative 8, what number times itself is going to give us negative 8. We've got to think small, because it's growing pretty big. We know that negative 3 got to be negative 27, so smaller than negative 3, or bigger because it's on the negative side, would be negative 2. So this is saying it's the negative of negative 2. Negative from outside, negative 2 from this radical part. So we have a positive 2 there. Okay, I want to look at number 76. And it has the cube root of negative 8 x to the 6th y to the 9th. So this is like saying it's the cube root of negative 8 times the cube root of x to the 6th times the cube root of y to the 9th. The cube root of negative 8 is negative 2, as we just saw. Now here's a kind of a trick you can do. The cube root of x to the 6th, 6 divided by 3. What is 6, this power divided by 3? It does divide nicely, so it's 2. So you get x squared there. And the cube root of y to the 9th, 9 divided by 3 is 3. So there's your trick, if you want to call it a trick. You take the power and divide it by the index of the radical. Power divided by the index. Let me see, here's 80. I'll do 80. 80 is another one of these with a cube root. Cube root of 81, m to the 4th, n to the 7th. So one way to do something like this is it can be helpful if you have something that is a number to a power. For example, 81 is 3 to the 4th power. That's 81. M to the 4th, n to the 7th. So we can do the same thing I just did. This becomes 3 to what power? Well, what's 4 divided by 3? Well, it's 1 with a remainder of 1. That is to say, 3 goes into 4 one time, That's this one on here with the remainder of 1. That's the one under the radical still. So this goes there, this goes there. And then this is m to the 4. Same thing. So you're going to have m to the 1, m to the 1. And then how about 7? 7 divided by 3. Sorry, wrote that the wrong way. 3 goes into 7 2 times. 6, so it's 1. So it'll be 7 to the 2 on the outside. So this power here, this is the power with the remainder of 1. So we have 7 to the 1 on the inside. So to clean it up, that's 3m. So it's n to the 7th, not 7 to the 7th. (3mn squared) times the cube root of 3mn. Let's try another one. There's one more I want to look at here. It's 83. It says the cube root of a, I'm going to give myself more space here. The cube root of a cubed b to the 12th over 27 c to the 6th. So the cube root of a cubed. Okay, well, power is 3. 3 divided by 3 is 1, so that's a to the 1. B to the 12th. 12 divided by 3 is 4, so it's b to the 4th. Over 27. Cube root of 27 is 3. And then c to the 6th. 6 divided by 3 is 2. That's it. Okay, one more problem we want to look at, like the square root of 7x minus the cube root of 7x. We can't do anything with that. We can't combine those. Those are just different. That's a square root, cube root. Cannot combine those. If they were both the same index, we could do something with them. That can't be done. Okay. Well, I hope that helps. Let me know. Thank you.